Hello and welcome to my channel. This is Donald C. I'm the author of A Hidden Mathematical Genius Within Revealed. Today I want us to talk about the following questions. Factorize completely 3x cubed minus 12xy squared, 16x squared minus 100, and 32x squared minus 50. So we know that these questions can be calculated by the concept of factorization. Okay, and we know that there are many types of factorization, or there are many types of how we can factorize expressions. And according to these questions, there are only two concepts that can be factorized or applied. Okay, and the first concept is factorization by common factor. Okay, so let's talk about factorization. So, factorization common factor. So, from the word itself, by common factor, it means you divide out what is common. So, for example, if we have an expression ax squared plus 3a, if you want to factorize this by common factor, what you do is you get what is common. Look at this expression, the first one, the first term here. This is a squared, and here we have 3a. So we need to divide out what is common. And in this case, we can see that there is a squared here, and there is a this side. So what we can do is we can see that a can go in a squared. So the common factor there is just a. Okay, so just get the term with the lowest power. So this a has a power of 1. This a here has the power of 2. So the one with a power of 1 can go in the one with the power of 2. So there the common factor is a. So you divide out a. So you put a, then you say a squared divided by a, you get a, plus 3a divided by a, you get 3, because a and a will cancel out. So you're going to have a, then in brackets, a plus 3. So we have factorized by a common factor. Okay. Another example, we can have something like this. 5b minus 15b x squared. Okay, so in this case, we need to factorize again. We'll say, first we start with the numbers. Here we have 5, and here there is 15. So again, the same concept. What you do is just look at the smallest. If the smallest number can go in the bigger number, then that smallest number will be the common factor, or highest common factor. Okay, so can 5 go in 15? Yes, 5 can go in 15. So 5 is our common factor. So we are going to divide out 5. Then again, we can look at the variables. Here we have a variable b, and in this term there is also b there. So we can also divide out b. Okay, so it will be 5b. So the highest common factor for this expression is 5b. So we need to divide out 5b. So we'll say 5b divided by 5b, yes, 1, minus this 5 in 15. 15 divided by 5, you get what? 3. Then b and b will cancel out. Then you remain with x squared. So we have factorized by a common factor. So we can see that the common factor there is 5b. So we divide out 5b, and in brackets we get 1 minus 3x squared. Okay, so that's about common factor. Then there is also what we call factorization by difference of two squares. So difference of two squares. So from the word itself, a difference of two squares. So in mathematics, if you hear the word difference, difference means subtraction. Two squares. A square number is just a number that have a square root. It's just a number with a square root, meaning a perfect square number. That is a square number. So it's supposed to be something like this. We can have a squared minus b squared. So this is an example of difference of two squares, because we have a minus in between, and this number is a perfect square because we know that the square root of a squared is just a, and the square root of b squared is just b. So when you have a minus in between two terms, and those two terms are perfect squares, this can be factorized by difference of two squares. And what you do is, you just say, what's the square root of a squared? It's a. Plus, what's the square root of b squared? You get b. So we're going to have a plus b. Then you repeat the same thing. You just change the sign. Here it is plus, then it will be a minus. So we have the product of a plus b and a minus b. That is how we factorize by difference of two squares. So if there is a minus in between and the two numbers are perfect squares, just get their square roots, you add and also subtract. Okay, now let's try to answer our questions using these two concepts. So, what you should always remember is that when you are told to factorize, here we are told that factorize completely. You can factorize, but it cannot be complete. So make sure that you complete your factorization. And again, if you see two terms, always start with a common factor. So every time you are told to factorize and you have two terms, start with a common factor. Okay, so our first expression is 3x cubed minus 12xy squared. So let's start with the common factor. So we have 3x cubed minus 12xy squared. So we start with a common factor. So what is common there? Let's start with the numbers. We have 3 here and 12 there. 3 is the smallest. Can 3 go in 12? Yes. So since 3 can go in 12, the 3 will be our common factor. So we get 3. Then we can see there is x cubed there and there is x there. The one with the lowest power can go in the one with the highest power. So that one with the lowest power will be our common factor. So x is also common. So there is no y there. So that one will be as it is. Okay. So our common factor here is 3x. So we have 3x cubed divided by 3x. So 3 and 3 will cancel out. X in x cubed, you get x squared. So we have x squared minus 3 in 12 is 4. Yes. So 4. X and x will cancel out. Then there remain with y squared. So there we have 4y squared. So we have 3x in brackets x squared minus 4y squared. So what we have done here is that we have factorized by a common factor. Now, look at what we have in the brackets. In the brackets we have x squared minus 4y squared. We have a minus in between. And we can see that this term here is a perfect square, because the square root of x squared, you get x. And the square root of 4y squared, you get what? Yes, 2y. Okay? So this is difference of two squares, because there is a minus in between and the two terms are perfect squares. So we'll say this is 3x, then open bracket, the square root of x squared is x. So plus the square root of 4y squared is 2y. And you repeat the same thing with a minus. So x minus 2y. So we have factorized by difference of two squares. We started with common factor. The next was the difference of two squares. So that's how we're supposed to do it. That was the first one. The second one is 16 x squared minus 100. So even this one, we start with a common factor. Let's go to the numbers. We have 16 and 100. We go to the smallest one. Can 16 go in 100? No. We are going to have a remainder. So 16 cannot go in 100. So in this case, you just find the highest common factor for 16 and 100. So what is the highest number that can go in 16 and 100 without a remainder? Yes, it's 4. 4 can go in 16 and 4 can go in 100. It's the highest number. There is no other number which is greater than 4 that can go in both 16 and 100. Okay, so in terms of the numerical values, 4 is common. There is x squared there. There is no x there. So 4 is the only common factor. So we'll say 4 in 16. 4 in 16 is 4. And there we have x squared. Then minus, what is 4 in 100? 4 in 100 is 25. Okay, so we have factorized by common factor. Again, if you look at what is in the brackets here, we can see that these two terms are perfect squares, because the square root of 4x squared is what? Yes, 2x. And the square root of 25 is what? 5. Okay, and there is a minus in between. So we can factorize by difference of two squares. So you maintain this 4, then you say, what is the square root of 4x squared? Yes, 2x. So we have 2x plus, what is the square root of 25? Yes, 5. Then you maintain, you repeat this the same thing, now with a minus. So we are going to have 2x minus 5. So that's how you're supposed to do it. Okay. We go to the last one. So the last one is 32x squared minus 50. 32x squared minus 50. So again, we start with dividing out with common factor. So the smallest number there is 32. Can 32 go in 50? No, there will be a remainder. So now, what is the highest number that can go in both 32 and 50? Yes, 2. Okay, so 2 is common. In terms of the variables, there's only one variable there. There's no variable there, so only 2 is common. So what is 2 in 32? Yes, 2 in 32 is 16. And there's x squared there, so 16x squared minus, what is 2 in 50? Yes, 25. Again, we can see that there is a minus in between here, and the two terms are perfect squares, because the square root of 16x squared is 4x, and the square root of 25 is 5. Yes. So we have 2, then we say open bracket, the square root of 16x squared, you get 4x, plus the square root of 25, you get 5. Then you repeat the same thing with a minus. So 4x minus 5. So that's the answer. That's how you are supposed to to do it. So every time you are told to factorize completely, and there are two terms, always start with dividing out with a common factor. After that, look at what you have in the brackets, if you can factorize by a difference of two squares. So difference of two squares, there must be a minus in between, and the two terms must be perfect squares. So you just get their square roots, the square root, then you add and you also subtract. Thank you so much for your time.